The reactions of acids with various substances are foundational concepts in chemistry, demonstrating how acids interact with metal oxides, metal hydroxides, and metal carbonates to form different products. Understanding these reactions reveals the underlying principles of acid-base chemistry and the methods used to create soluble salts. Metal oxides and metal hydroxides are classified as bases because they can react with acids to neutralize them, producing water and a salt in the process. A base is defined as a substance that can accept hydrogen ions, H, or donate hydroxide ions, O, in a chemical reaction. Metal oxides, such as magnesium oxide, milligrammo, and copper, oxide, CuO, and metal hydroxides, like sodium hydroxide, NaOH, and potassium hydroxide, KOH, possess this ability because they either contain or can generate hydroxide ions when dissolved in water. When an acid reacts with a metal oxide or metal hydroxide, the hydrogen ions from the acid combine with the oxide or hydroxide ions to form water, and the remaining ions form a salt. For example, when hydrochloric acid, HCl, reacts with sodium hydroxide, NaOH, the reaction is as shown on the screen. In this reaction, the acid's hydrogen ions, H, react with the hydroxide ions, O, from the base, producing water, HO, and the remaining sodium, Na, and chloride, Cl, ions form sodium chloride, NaCl, a soluble salt. When acids react with metal carbonates, they produce carbon dioxide, along with water and a salt. Metal carbonates, such as calcium carbonate, CaCO, or sodium carbonate, NaCO, contain the carbonate ion, Co². When an acid is added to a metal carbonate, the acid reacts with the carbonate ions to produce carbon dioxide gas, CO, water, HO, and a salt. The reaction can be generalized as shown on the screen. For example, when hydrochloric acid reacts with calcium carbonate, the reaction is as shown on the screen. In this reaction, the calcium carbonate, CaCO, reacts with the hydrochloric acid, HCl, to produce calcium chloride, CaCl, water, and carbon dioxide gas, which is observed as bubbles in the reaction mixture. You can make soluble salts using an insoluble base by carefully controlling the reaction between the acid and the base. An insoluble base, such as copper, oxide, CuO, will not dissolve in water, but it can still react with an acid to produce a soluble salt. The process typically involves adding the insoluble base to the acid until no more will react, ensuring that all the acid has been neutralized. The mixture is then filtered to remove any excess insoluble base, leaving a solution of the soluble salt. This solution can then be evaporated to crystallize the salt. For instance, to make copper, sulfate, CuSO, you would react copper, oxide with sulfuric acid, HSO, as shown on the screen. In this reaction, copper, oxide reacts with sulfuric acid to produce copper, sulfate, a soluble salt, and water. The unreacted copper, oxide can be filtered out, and the remaining solution, when evaporated, will yield blue crystals of copper, sulfate. These reactions of acids with metal oxides, hydroxides, and carbonates illustrate the versatile behavior of acids in forming different compounds, such as salts and gases, and highlight the important role of bases in neutralizing acids. Making soluble salts from insoluble bases is a common technique in chemistry, demonstrating the practical application of these reactions in creating useful chemical compounds.